This is number 3 from the mathematical induction practice quiz. We are proving that n squared plus 3n is divisible by 2 for all positive integers n. So I've set up the first case. I have n equals 1. So that's n squared plus 3 times 1. I'm sorry, 1 squared plus 3 times 1, which is 1 plus 3, which is 4. Since 4 is divisible by 2, our n equals 1 case works. All right, so I have the induction step set up. We're saying if k squared plus 3k is divisible by 2, and now we're going to show that the k plus 1 case is also divisible by 2. So it helps to do a little algebra to start. Really, as I look at this, there's nothing, I don't see anything that I can break up. And we could factor out a k plus 1, but in this case, that's not really going to help us. If anything, we want to kind of match this guy. We know this original statement is divisible by 2, so if we can get k squared plus 3k, that will help us. So we're going to just do some multiplying out here. Remember, k plus 1 squared is k plus 1 times k plus 1. I'm going to go ahead and multiply this 3 through. And I see something that I like already. Remember, we can use that original statement, k squared plus 3k, and I have a 3k right here. So I'm going to try not to combine that with anything else as I work forward. I'm going to go ahead and multiply out k plus 1 times k plus 1. So this proof will go off the rails right now if you combine like terms. That's why I identified that 3k is important in basically that first algebraic step. Because right now, we can group together 3k and k squared and say that that is divisible by 2 from our assumption step here. And then let's see what we have left. We have 2k plus 1 plus 3. So that's 2k plus 4. You should be happy right now because that looks pretty nice. If you group these, we have k squared plus 3k plus 2 times k plus 2. Sorry, I ran out of room there. Here, let me write that on the next slide for you. So k squared plus 3k plus 2 times k plus 2. And I just rewrote that 2 times k plus 2, that was our 2k plus 4. I just rewrote that so that it looks divisible by 2. There we're showing it's divisible by 2. So if we break this up into pieces, this first piece is divisible by 2 from our assumption step. And then 2 times k plus 2 is divisible by 2 since we can pull a 2 out. Since that 2 is pulled out, that's also divisible by 2. So the only thing that we really need to deal with here, the only thing we have left, is this plus. And what do we know about two even numbers when we add them together? Anytime we add two even numbers, we get another even number. So the sum of two numbers divisible by 2 is also divisible by 2. And we've satisfied conditions 1 and 2, therefore our statement is true. You do need these last 3 bullet points in your proof for your proof to be complete on a problem like this.
Made with Doodlecast Pro.